Hi everyone, my name is Neil. I'm the co-founder and CEO of Dawn, and we're building a protocol for providing decentralized broadband.
Hey everyone, my name is Jon. I run the engineering team at the Solana Foundation, spend a lot of time working on product primitives and helping people join the Solana ecosystem. And I'm also the organizer of a conference coming up in a couple weeks called Accelerate.
Just good to talk about Jon, about what we're building. You know, we spoke with Jon a long time ago when we were very early on in our journey, but we've come a long way in terms of getting clarity about the type of system that we really need to build on chain. So at the very least, it's a good opportunity to give the updated spiel to Jon about all this stuff. When we were talking about that, I guess, what was your first impressions of Dawn?
I mean, it's interesting because my first impressions of everyone is like, first it's like, one, do you have a product in a business? Second is, are you the person to do this? And the third is, why blockchain? Because you can have the first two in spades, but if you don't know why blockchain, then it's like, okay, where is this all fitting together? And I think the product, like, it was clear to me what it was. At that time, it was like apartments and a smaller vision than what you just mentioned, but still very tractable. The second one was like, do you know your shit? Which is absolutely true, and that you've proven, over and over again.
We'll see. Yeah.
But that was clear. And the third piece is, always just reinforced with every conversation is why blockchain.
Yeah.
And I think that's an important skill to have for whatever the product and business is.
Because like ever since we were originally talking about, our goal is essentially just bringing telecom or a big chunk of telecom on chain. We think about it in terms of like the OSI model, right? So we think about like everything from like layer 1 all the way up to layer 7 for applications. And our goal is to represent layers 1, 2, and 3 on chain using wireless as kind of the bedrock for that communication. So like one of the ways that I like to think about it's like, how can we just essentially put Maxwell's equations on chain and just see how the entire network evolves by that, right? That's of course a very direct way about doing it, but in general, you have to do everything from kind of representing wireless transmissions on chain to doing individual bandwidth contracts with people and even subscription plans, right? So the idea is really just being able to bring an entire marketplace on chain of people that have these resources and then giving them the ability to sell it and monetize it in their surrounding area. And of course, there's like a lot of interesting mechanisms that come from that, but one of the key themes is when you're bringing a network on chain is a network because of hardware, spectrum, IP space, by definition, has a bunch of different scarce resources. And then kind of one of our philosophies to that is people will get access to those scarce resources through a staking mechanism. And so you can see that kind of once you have a very robust PDA-derived abstraction of your state of your network on chain, you can mediate the resource exchanges between those through staking and secondary marketplaces, and then evolve that state based on when people buy and sell new internet subscriptions. That's really kind of like our high-level goal.
It's cool to see how you're thinking about representing different things on chain, whether through tokens or NFTs or even just data, like, and recording ththings, right? So that's the part that I think would be interesting. To the extent you talked about layers 1s, 2s, 3s, these are not like roll-ups, but they're like, a whole bunch of other like networking things. What things are you putting on chain, and what is the most critical part of Dawn that needs to be on Solana?
Yeah, so the way that, so to give a little bit of an additional backdrop to how I answered this question, the role of the protocol for us is actually designed to solve a very simple question that I'm kind of surprised no one's asked this question at scale. It's how do you connect people that don't trust each other, right? Like ever since we've built the internet from the 70s and all of the protocols that were involved with TCP IP and all that stuff, you're essentially assuming trust as part of that equation. But we're now in a scenario where wireless reduces the barrier to entry to participate. So you have to ask this question at a massive scale, right? We have asked this in a localized scale, like technologies like Wi-Fi, right? They have security on top of that. But if you're looking to build something that is a macro wireless network, again, connecting people that just don't trust each other, there isn't really a suite of protocols that allows you to be able to capture that. And I think it's a problem that has to be solved at some point, which is why I think it's interesting. And then so to get to your question about what we're trying to bring on chain, it's pretty much all of the different resources that are required for that trustless exchange of internet resources, I guess, to facilitate. And so if you think like on the physical layer, like one of those things we're bringing on chain is like, what is the spectrum that people are using to be able to talk into this? And so if you consider like what is the end state of this is in simple terms, it's like bringing the entire FCC on chain, right? Like that's part of what we have to build. And so you can see a world in the future where like spectrum auctions can actually happen on chain, right? You're just mediating the exchange of these physical resources, and then you're just holding people accountable to that. So I'd say like in layer 1, spectrum is probably the easiest way to think about that. When we think about layer two, like kind of like a layer above that, that's actually like me connecting directly to you, right? Like a data link layer. And in that scenario, we actually have to deal with like ephemeral certificates that are kind of saying, hey, you and I are going to connect for a span of a year, and we're going to use these certificates to be able to exchange connectivity information, right? So it's essentially bringing that low-level MAC address information on chain, and then tying certificates to have like secure communication. And then I can say like the third and final layer is like IP address information, like global routing. How does your node actually participate in a greater network for delivering packets? And so it's kind of, if you look at like everything that's being used today to represent those things, right? For layer one, you have stuff like the FCC, right? That represents that data. For layer two, you have like source of truths and on-chain, or not even on-chain, but source of truths and like representations for like IT networks, right? Folks that are either doing this in spreadsheets or sophisticated software. And then in layer three, you have technologies like BGP, OSPF that are doing routing for the entire internet. So it's really all of those mechanisms being put onto chain, and us taking like a lot of inspiration from how those data models are done, and then just recreating those in PDAs. Like that's the rule book for how we do engineering, I guess, on our side. Is we look at what was done well from like, IANA and Aaron and all of that kind of stuff, and just try to bring that stuff on chain.
Yeah, that makes a ton of sense. Where have you found constraints or like things that haven't worked as well as you wanted them to?
The biggest constraints that we deal with is, and this is like where we kind of talk about like state compression, is like we want to figure out how do we deal with just the limited size and rents, right? Essentially, we're like constantly dealing with the scenario of like, how do we remove the rent fee, the 2-year rent fee on our side of stuff.
Yep.
And so that's why we're in a scenario where we think about like, how does our indexer become a core part of the entire protocol?
Yep.
And then once we're in that scenario, we're like, how do we decentralize our indexer and all that kind of stuff that comes out there? But I think to one of the things that we were talking about earlier is like state compression is like a great a bridge between those two worlds, And so I think that the cool part about Solana is that you're always finding a bunch of these little tools that kind of make it easy to solve these problems at scale,
Yeah, I mean, we built it for this exact reason. We were trying to think about how could you have like things like millions of NFTs on chain and not have to deal with that rent cost, because the reality is you don't really need that in-memory like account state.
Yeah.
But you need cryptographic proof that something is the way that you think it is, right? So that's what the hashes are for. And so using state compression, you can, for NFTs at the very least, you're sort of like hashing who's the owner, and you're able to update that hash over time. And in the same way, you're hashing this data, but you're not losing the information because the data is on chain in the ledger. Right?
Yeah.
So if you have a copy of the ledger, you can reconstitute all this stuff. So it's great that you're using it for these kinds of.
Where there's a lot of interesting things you have to solve, like, okay, if inference is the real resource, but it's ultimately derived from a physical machine, you need some way to validate that the inference is at the quality that you want it to be at.
Yep.
And so we have the same thing, but I think there's kind of 3 major things. Right? We have proof of backhaul / bandwidth. What is the speed that a node is actually, what is the capacity that a node has to be able to route packets to the internet? And so obviously we want to reward people more if they have more data to be able to share. Then there's location, right? Where is the physical node that is actually transmitting this? And the final one, what's the frequency that they're using? And between like bandwidth, location, and frequency, you more or less have everything you need to be able to build a trustless sense of the system. And so the way that I kind of always pitch is like, hey, Solana provides that data consensus layer. Like Solana is essentially the rules by which we construct an arbitrary topology on chain and then evolve that topology. And then our goal on top of that is to take that and make sure that it's implemented in the real world, and then we hold people accountable for implementing it accordingly.
Yeah. How do you scale that, not the accountability part, but how do you know if someone's not providing that? How are you scaling that?
The way that we've approached it, like this is kind of like where our Chrome extension validators come in, is people that are outside the network, or in some cases inside the network, that are using some of their latent resources to be able to challenge and probe that. Okay. So in the case of like proof of bandwidth / proof of backhaul, you have people that are outside the network that are just essentially doing a synchronized DDoS attack on a given node for 1 second to validate the capacity that they have. In the case of proof of frequency, you have people that are automatically having their radios scan the surrounding area and reporting all of that information back to it. So it's the simple answer is that it depends entirely on the individual use case. But the major thing that we found is kind of the right rule book for this is you incentivize people to use their latent resources in an automated way to be able to participate. And there's a lot of cool stuff that you can do on top of that, like having stake be kind of the decider of who gets to validate and all that sort of stuff. And I'd say like that's kind of, I guess, one mechanism I'm excited to see how that stuff takes place in Solana, right, over time.
Yeah, I think I've noticed as I've worked with a lot of deep-in teams, there's similar patterns. One of them is obviously like the asset or the resource that you're providing, but the second is the adversarial, how can you check this at scale? And
Yeah.
so the challenger thing is quite interesting, and ultimately what that reward ends up resulting in is the reward cycle, and that, so there's like 2 or 3 different components that I see across all the different projects.
Yeah, and it's funny too, is like when you look at like what is, like suppose you are, buying any ordinary Web 2 service like internet, right? A percentage of what you're paying for that is overhead that goes to the company to provide security, recourse if your service isn't the quality that you achieve. And the nature of kind of how we see validators is validators are kind of doing that on their own, right? Like you don't need to pay 3% overhead on extra margin that goes towards your internet service provider when you can just do that to other people that are doing the same thing for you effectively. Right.
That's really cool. It's just like this is just a brand new space to innovate in that like didn't exist or just couldn't work in a Web 2 world.
Yeah, totally, right. And that's like the part that I kind of mentioned earlier is like that simple question of like, how do you connect people that don't trust each other? Like it's crazy to me that there isn't a really good like textbook answer for how to do it, what are the set of protocols that govern it, and now that we're in a scenario like really 2024, 2025, wireless technology is good enough that it forces us to answer that question. And I think the cool part about this is like if we do our jobs right, we're kind of creating this global standard for how all wireless will work for the next 50, 100 years of communication. And it'd be pretty cool to see kind of Solana have such a key role, like the same way that TCP/IP did back in the 70s,
You mentioned something earlier about, wireless, but that means a lot of things. It means everything from cell phones to Wi-Fi to a whole bunch of other things. First off, what does wireless mean and what does that mean in the context of Don?
Yeah, so the way that I think about it is there's kind of like a clear end state that we in technology, radio technology, everything is kind of sprinting towards. And it's a dream that I think is from like the late 90s, early 2000s that was pioneered by this project out of MIT called Roof Mesh. Roof Mesh. Well, I'm getting it wrong. Yeah, Roof Mesh. And the idea was like, hey, we have these DSL gateways. What if all of these students could kind of have these little, like in their case, 900 megahertz transmitters that would kind of form this one mesh. And so I think when you look at kind of the evolution of wireless from where we are, we're clearly sprinting towards a world where almost everything can be a little micro transmitter and participate in a global fabric of connectivity that you can get your data from one place to the other across an inter-network, right? Like that is kind of the end goal. And so I'm operating under the assumption that is going to happen at some point. I have the firm belief that at some point the technology is going to keep getting better, where every little device can be a little transmitter. You're not going to need a phone plan. The recorders over here are going to be able to mesh to my phone, which might broadcast to you and then broadcast to somewhere, and that just goes out to the world. So that's the end state that I'm kind of building towards. I'd like to think similar. Solana has their own end state that you guys are building towards. And in my case, the way that I think about this is, when does the intersection point happen where it actually makes sense for an individual to participate in that dream, right? That is, I think, the important part that we bring ourselves to here is we see that moment happened once wireless was able to do point to multipoint in a multi-gigabit fashion, right? When one node can talk to many other nodes in a multi-gigabit capacity, that's the threshold, right? And of course, cost is a huge element of that, but the cost has actually followed quite nicely, where now that we have the cost and the technology, the curves have kind of intersected where it makes sense for people to participate. And then so to get to your question about like, what does wireless mean here? It means one person is using their spare bandwidth to broadcast signal to other people, and it's actually a profitable experience for them. That's the nature of what I think about is wireless. And so what I see it kind of manifesting on our system is kind of like a decentralized Airbnb for surplus connectivity, right? People can just enter this marketplace, they can see the list of all of the options that are available to them, and they can choose the one that is right for them, and it's coming from somebody in their community, right? That's really what we're building towards. And that whole kind of, I guess, a little bit of like a diatribe about the end state of wireless and where we are, that's the part that's been fascinating to me, is that there is that cutoff point where it makes sense for an individual person to become a participant, right? In the 70s, it didn't make sense for even a regional fiber company that didn't exist, but a regional fiber company to participate in ARPANET, right? Like the barrier to entry has come down and down and down of telecom over time, and wireless represents a massive step function for when that barrier to entry comes down. And now that the performance is good enough to compete, that I think is kind of this interesting inflection point that we find ourselves at.
That's interesting. How do you think about like the user experience? Because I think that folks like ourselves might have a better sense of what these options look like or what capabilities they provide. But how do you think about the end consumer who doesn't know about anything?
Yeah, the end consumer experience, I think we try to replicate the existing models, right? Is that you have a couple of different plans that you can choose from. You have essentially like a little broadband fact label that tells you what are you getting out of this entire thing. But then it ultimately comes down to like a cost, availability, uptime perspective, right? And by doing all of this stuff on chain, you have a trustless way to see what is actually the quality of this plan that they've provided to other people. So I think it gives consumers better insight and transparency in that stuff. But then a lot of that just comes down to effectively how do you distill that? And that's been kind of like a big part of what we've been building is like when we have our entire mobile app, right? We believe like it's a mobile first experience for the way people ought to interact with this sort of infrastructure. So a lot of it is just like making life easy for them so that they don't have to think about that. How do you guys actually see like the complicatedness of blockchain becoming more accessible to like everyday users?
Yeah, I think, relative to other chains, I would say Solana does take a little bit more to understand, just because you do need to understand state and all that sort of stuff. And I still think there will be a room for advanced folks to really dig in, but that's good. You want to be able to tinker with things and make sure that it's optimized. I do think like over time, we'll start to see more and more materialized APIs that really abstract away the hard parts. Like, look, most people don't care about when this transaction gets in. If it's 1 second or 10 seconds, it doesn't really matter. Just get this transaction.
Yeah.
And finding ways to surface that in ways that Web 2 developers are very accustomed to, right? Most Web 2 developers don't think about things like cryptographic signatures. Maybe it is hidden behind the hood or something like that, but trying to make sure we're meeting them where they are and not making it this foreign concept, right? The foreign concept is digital ownership. That's a whole nother, bucket of worms, bag of worms.
Bag of worms.
Bag of worms.
Bag of worms,
Yeah. But, I think that is okay to hold off on and really focus on just making it easy to understand in the words that they understand.
Yeah, and so this is interesting too, because I think like I look at like other interesting Web 2 sources of kind of like decentralization that provide some level of utility that aren't crypto. And like obviously you have stuff like uTorrent, for example, and the technology behind uTorrent that allows these nodes to discover each other, talk through a firewall is this thing called Hyperswarm, right? And it's essentially this distributed hash table that allows people to propagate and kind of do inter-process communication on top of it to be able to establish a connection. And you could see a lot of analogs with kind of how Solana does that, right? And so the part that I'm always curious by is like, what is that major Web 2 developer use case that makes it a no-brainer? Because in the case of like Hyperswarm, they still need to have bootstrapping nodes, right? You need to download that hash table to be able to participate in this entire network. So they have kind of provided that gateway in like a dead simple way where I don't have to think about it. I know that from a decentralized peer-to-peer perspective, it just works, and they kind of provide this little bootstrapping layer. And so I'm always curious, like, is Solana going to have like that kind of breakthrough moment where like, hey, we just do a Web 2 utility better than other people as a result of all this Web 3 stuff?
I mean, peer-to-peer value transfer is the most basic form of money, digital money at the very least. That's what Satoshi put in the white paper for Bitcoin, right? And if we can do just that, I think that can fundamentally change the world.
Totally, and to give you a little bit of color of how we've been using it, like when we build our, when you see the block diagram of all the stuff that we going on, you're gonna love it. But the way that we've thought about it is like, all IPC, inter-process communication, as much as possible, gets intermediated through the chain, right? Assuming that it's not a massive amount of data and it doesn't need to be stored perpetually, it's kind of like a great message broker, essentially. And we've been using that to both evolve the state so you can see how the network is evolving over time, but then actual messages are passed along there. And so it's been so much better, I guess, from our perspective, that we don't need to think about how do we deploy like a global gRPC mechanism or any type of DevOps infrastructure to be able to intermediate those commands. You can build, it's kind of like microservices on steroids, right? Like that's kind of how we viewed the architecture side of stuff. And I can see when you're a developer that wants to build this application, I can actually see a world where it's like, why would I deploy my own microservices architecture when I can actually just rely on Solana to handle the messaging layer between all of this stuff? And I do it in a way that just gives me maybe not like ACID compliance, but full trustlessness of the evolution of what my application ought to be doing.
Totally. I think it simplifies a lot of kinds of products. Blockchain's a multiplayer game. It definitely helps facilitate a lot of those multiplayer type connections where you're sharing data across different places. I've found that I've lost all my Web 2 database skills because I don't need them. Right? Servers, materialized views, APIs, things like that are helpful, but ultimately you can kind of put all this state away into this global database, and it helps with so many different things, because you're doing the same things with any kind of asset. You're transferring them between different things. You're doing that in the Web2 world as well. It's just about, okay, can it keep going? Can it be transferred to these other places? So I do think that that's a nice sort of abstraction that we've seen, is just, the state, you don't have to think about it at all.
What I appreciate about Jon and the way that he goes about Solana is that he's got a deep technical understanding, but you're in so many different operational stuff that I just don't know how you do it. I don't know, like when you're just telling me about Solana Accelerate, I'm like, dude, how does this guy operate as head engineer, but then also do this sort of stuff? I can't wrap my head around that.
I only do half of one of those jobs, so. What I appreciate about Neil, he's like the biggest nerd. I think this is cool. Like, I think that nerd feels like it's a bad term. It's a great term, right? And I think that anything that gives you the joy of being like, hey, I can do a thing without having to hire a massive team, without having to be a massive corporation to be able to accomplish and make a huge difference. Like, you can only do that in one place, and it's in crypto. So it's always a joy to hear more about the development of the hardware side of things is really awesome, but also just how you're thinking about working with other people.
Dude, thanks for hearing me on, man.
Of course.
Thanks, man.